We're trying to figure out how many combinations of 3 passengers can be formed from 5 friends. So he has a car, he's got 5 friends, all of them want to ride in the car, but it only holds 3 at a time. So I want you to know that if Sally, Ron, and Rita are chosen to ride in the car, that's the same thing as Rita, Ron, and Sally. What I'm trying to say is order does not matter. If order does not matter, then it's a combination. And the formula is N choose R. And that means 5 choose 3. And the formula for this is N factorial over R factorial times N minus R factorial. So N is always going to be larger than R. And in this case, N choose R. I want to do 5 choose 3. That's going to be 5 factorial over 3 factorial times 5 minus 3 factorial. So that's 5 factorial over 3 factorial times 2 factorial. And factorial means like 5 factorial is 5 times 4 times 3 times 1. Or I could write that as 5 times 4 times 3 factorial. Stop in the numerator at the largest factor in the denominator. So you can cancel that out. So I've got 3 factorial, and then 2 factorial is 2 times 1 or just 2. So those cancel, and 2 will go into 4 2 times, and you're left with 10. Now, if order had mattered, so that's the answer to this problem, but if order had mattered, it would have been a permutation. And a permutation is N choose R, and that's N factorial over N minus R factorial. For example, if you were, see how many slates of officers where the first position's president and the second one's vice president and the third is treasurer, these two would mean 2 different things. So the permutation is when order matters, and combination when it doesn't matter.